Archimedes Principle. Most of us have felt a lightness come over us when we step into a pool of water or a bathtub. We feel lighter. A stone, when held partially or fully immersed in a body of water, feels significantly lighter. This is a consequence of upthrust, an upward force exerted by the fluid which is proportional to the density of the fluid as well as the object immersed in it. This behavior is shown by all fluids. Even the air in the atmosphere displays this effect, and it was first investigated in detail thousands of years ago by Archimedes. As a result, the principle now bears his name. Stated briefly, when an object is immersed fully or partially in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced by it. This effect arises from the fact that in order to displace a certain volume of a fluid, the object must use up a certain amount of force. Thus, it reduces the total force exerted by the object due to gravity. In simpler terms, it reduces the weight of the object, which is what we feel. The weight lost by the object is exactly equal to the weight of the liquid displaced by the object, which in turn is equal to the density of the liquid multiplied by displaced volume, multiplied by acceleration due to gravity. Archimedes' principle is of great value in the measurement of density without physically damaging an object. He famously used it to determine whether a supposedly pure gold crown was alloyed with silver. It has also been used in the design of lactometers, which test the purity of milk, and hydrometers, which check the strength of battery acid. Relative density. As we know, density is a ratio of the mass of an object to its occupied volume. The density of a pure substance at a given temperature and pressure remains constant. Thus, it is an intrinsic characteristic of the material. For example, the iron used in your kitchen knife and the iron recovered from a meteorite have the exact same density irrespective of their source. It is often convenient to use a shorthand method of comparing density. The density of a given material is compared to a pre-decided standard. This standard material is pure water at 4 degrees Celsius. Thus, relative density is equal to density of pure material divided by the density of pure water at 4 degrees Celsius. As it is a ratio of two densities, relative density is a pure number with no units. The concept of density, relative density, sinking, floating, all of these are interrelated, and it is understandable that they can be a bit confusing. A young student once asked me a question, ki, sir, why does a piece of iron, if thrown in water, sink while a ship made from that same iron floats? And I think this innocent question gives us a lot of insight into the concepts of density and relative density and why objects float or sink. It is important to understand that when we define density of a material, we are referring to a solid material. So when I say the density of copper, I refer to a solid chunk of copper which has no empty space inside it. When I say the density of diamond, I am referring to literally a chunk of diamond which has no empty space inside it. So if you take a piece of iron, it can be a sheet of iron, it can be a chunk of iron, it can be a cube or a cylinder. It doesn't matter what the shape is. If it is a solid piece of iron, its density will be whatever the standard value of density is, which is significantly greater than water. And as a result, if you throw this object in the water, it will immediately sink. On the other hand, a ship is not a solid object in the sense that it contains plenty of hollow spaces inside it. If you think back to the definition of density, it is the mass of an object divided by its total occupied volume. So even though we have built the ship out of a dense material like iron, we must remember that the size of the ship is not completely filled with iron. It has plenty of hollow spaces inside it. As a result, the density of the ship as opposed to the density of iron is significantly less than water, which is why a ship made from iron will float. Another interesting application of varying density is the operation of submarines. As you may or may not know, a submarine is a special type of vessel which can operate both over water and underwater, used by the Navy. The principle of operation of a submarine is actually pretty simple. All we are doing is changing the density of the submarine with respect to the density of water. At its core, a submarine is simply a large enclosed volume which contains hollow spaces inside it. Due to this hollow space, the effective density of this submarine is less than water, which is why the submarine, like any other ship, floats on water. The submarine contains special tanks inside its body which are known as ballast tanks. When you want to change the density of the submarine, we simply fill these tanks with water. If you fill the tanks with water, the effective mass of the submarine is increasing while its occupied volume remains exactly the same. If you think back to the definition of density, an increase in mass for the same volume causes an increase in density. The increased density causes the submarine to sink in water. A submerged submarine, if it desires to come back up, will simply remove the water from these ballast tanks. As a result, the amount of hollow space inside the submarine increases, the volume remains the same, but the mass is decreasing as we have pumped all the water out. As a result, the density of the submarine is now less than water and it will float to the surface.